All right, this little sequence in this video that you're going to see here is something I filmed in the garage last month, about the beginning well, it was right before the 12th. I was leaving for Mexico on the 12th of the month, and it was the weekend before that, and I was having a problem with this setup with that parallel spindle thing of the previous videos. And the issue was the way I mounted it on the machine, not the device itself. It worked fine, but the way I mounted it, somehow I was just using regular cap screws to hold it onto the face of the spindle with the original stud or screw holes in the spindle face. I took the cap screws out that hold some of them that hold the spindle face on the machine itself, and I just used longer socketed cap screws. And I have this, how do I explain this? This area where I've sealed off so that I could use the flood coolant that comes out the spindle normally to go out and through a lock line, coolant line over to the where the machine was taking place. And I checked the holes in the spindle face, and they were blind holes. There was no apparent way that coolant could get through there, but apparently the coolant has enough pressure to get through the little gaps there into the spindle housing, and I didn't know this, and so I had that problem. I took one of the covers off the spindle, and there was a residue of coolant in there from what I was doing, so I had to make new studs. Here's one of them. You'll see it being made in this video with an O-ring seal that seals on the counterbore in the spindle face itself, where the socketed cap screw's head normally is recessed in the spindle face. And I could tighten this with this hex on here. You can see it. I don't know if you can see, with a wrench, and tighten it down as if it was a normal screw. And then this section here was holding my attachment onto the spindle face, and this cured the problem. But I was starting on this the weekend before I was leaving on Thursday, and I had to do the parts, and I was in a big hurry to get the job done, so unfortunately I didn't have time to film and make a video of the actual machining being done with this parallel spindle device. But I did film making these in the garage the very weekend, like the Sunday before I had to go and do the machine work the next 2 days, and then get ready to leave on an international trip to Mexico, which I didn't get back till the end of the month. So I was in a big hurry, and so I did, in the video I even say so, I did a lot of things just because I'm in a hurry. I can't spend too much time trying to find things in the garage. I've got the garage in a big disorderly mess right now because I've got all kinds of stuff all over. You may not notice it in the video. I don't think you can see it, but so anyway, that's what this video is about, just making these little studs. I need 4 of them. I can go over here. Let's go over here and look. And I'll show you where these went. They actually went in this hole, and those 2 holes opposite in the spindle, and they went in here like this, and they sealed on the counterbore. And apparently the spindle flood coolant has enough pressure on this machine that even though these gaps are very small here, it could leak through. It didn't get into the spindle itself. The spindle and the bearings and everything were fine, because I have an O-ring seal here and on this OD that seals it all off. But when I took this cover off, and I could see coolant got in there somehow. So I had to cure this issue in a big hurry, and then actually do the machine work. This is the, as you might have seen in the previous videos if you watched it, this is the fixture, with the spindle. This is taken off the machine, of course, and this would cover the, the belt that's driven from the spindle of the machine with this sort of like a tool holder with a sheave for the belt on it. And all of this gets bolted on the spindle face, and I had to put these little recesses in this to clear those hexes that I had made. So an O-ring goes in this groove, and then this O-ring seals in the flood coolant, you know, pressurizes this whole area so that it can come out these lock line coolant lines. Now I had a whole additional problem, and I said in the video I was going to show doing this on the Haas and putting these counterbores in here to clear this on the little Haas in the garage, but another thing happened which is kind of weird. Is there's a timeout feature on all Haas machines, so that when you buy the machine they give you, I don't know how many hours, you know, 300-400 hours you can run it until you actually finish the financing and pay for the machine. And apparently my machines I bought in 2005, and apparently they've had this trouble with the machines, other people's machines too, that timeout feature reinitializes itself. And of course, right when you need to do something, the timeout feature timed out on the machine in the garage. Right the Sunday I was working on this, trying to get it done, because I had 2 days to finish the job, the machining, and it timed out, and it was a Sunday, and I couldn't get with Haas to get. I have since corrected this problem, but apparently this can happen, and I don't know how, but many years later that timeout feature can reinitialize itself, and then you're running out of time, and the machine just shuts off. You can manually jog it, which is the way I put those counterbores in there. I just manually jogged it to the positions and put them in, but it won't run in the auto mode. So that also happened to me. So a host of things, I guess you could say, were kind of working against me to get this job done, and so I had to do it in a big hurry, and I only had 2 days to complete the whole thing after I got these special studs made and worked around the Haas not wanting to run because of this timeout feature that Haas puts on their machines, and got that thing back, mounted it back on the Mazak, and did the actual boring job on the parts. I'll see if I can take some photos. I think the parts are still sitting here. This is an assembly that is, that's just one part out of a bigger assembly that gets electron beam welded together, and it's like, I don't know how long, like 12 feet long when it's finished. But anyway, so this is the only thing I was able to actually record that had to do with doing that job. I was going to put this all together in a video I had intended to, but it's a little bit more difficult now here because I'm actually working for somebody and I can't just stop what I'm doing and make videos, although that has changed a little bit now, the way I'm going to get work for them or do work for them and get paid for it, and I'll have more time, I think, to make videos to show to you guys. I think that could work out pretty good now. In the last year, almost year, I've been actually working for Centerline, and I haven't been able to really, well, I can't do it on their time, obviously, and they don't mind if I make videos, but I have to work it out so that I'm not actually doing it on their time. So we've changed the way I'm going to get paid for doing machine work on parts, and I'll have time to do that now, I think. We'll see. So anyway, that's what this video is about, making those little studs, and it's just something I had to show you guys. I did take some video of what's going on with the thing in Mexico when I was there a little bit, and I might make a video of that and post it, but this is more what the channel's about, is machining work, and so that's what this video itself is going to be about. I just want to explain that because it's kind of hard to tell what I'm doing here. This is all in my garage, this video here. And also, I haven't had a lot of time to get in the garage and clean up things and do stuff. about, I don't know how many years ago, 3 years ago maybe or so more, we had this hurricane that flooded our house. We had to have the house all rebuilt, and also messed up the garage a little bit. It got a little bit of water in the garage. The machines were fine because they're high enough above the ground, but anyway, and ever since that hurricane, things have been kind of disorganized, and I haven't been able to really work too much in the garage. I have a problem with the Haas mill with the tool setter probe. Has an open circuit on it. I have to fix that, and the rotary axis, the A-axis, is somehow malfunctioning, and I haven't been able to get to all these things because of working and the hurricane issue that took over a year to rebuild the house because of the flood water we had in the house and everything. So anyway, the garage, the machines still function, but they're, with the high humidity in Houston and everything, you got to get in there and clean things off because stuff rusts and corrodes and everything. So anyway, if you're still with me and you want to watch the video, you know, that's what the video is about. I wanted to explain that because it's kind of just hard to interpret what I'm doing here unless I explain it. So enjoy the video. All right, I'm turning these special studs, I guess you would call them, to seal off the on the Mazak, that parallel sub spindle has these screws, but I need to seal off the screw, and then there's going to be a threaded end like this on this end of this. So there's going to be an O-ring in here and a small section of hex to tighten this into the spindle face itself, and then the rest of this will hold the attachment to the machine. It needs to be sealed off here because coolant has gotten into the spindle, and I need to make these things to seal it off. So this is the first end. I prepared all the blanks with a center drill. Stick it in the collet. Stick it out 3.5 inches. Close the collet. Then I have to put, I use tool number 1 on this machine as my reference tool. So I have to move the camera here a little bit. It's in the way of my the tool post. Here. I have to stick it on here a little bit different here. I don't know if I could do it this way. Let's see, we'll see. And I've got to extend the tail center up here. Put the machine in a manual mode. First I got to change to tool number 1. This is this tool here. You can barely see it. I'm going to change to manual mode. Extend the tail center. And I have to move the camera again. I don't film too much on this machine, so figure out how to do it here. What I've got to do is touch the because I use this number 1 tool. This is kind of like my roughing tool, but I'm not using it in this program because I can't get down to the diameter I need to next to this tail center. But I need to use it to touch off my Z0. So here I've got to go and just teach it. That's the 0 point. That's all that does, just to set the 0. Now, let me see. This is tool number 1, 35-degree diamond. If I had I don't have a tool holder for a 55-degree diamond insert. That would be a little bit better to rough this with. I just have this one, so I'm going with that. And I'm just going to put I think this is Tap Magic on here, just so we can kind of see what's happening with the video. It kind of smokes a lot, but this was the only insert I had for this 35-degree diamond tool. On this machine, I rarely use inserts with big tip radiuses. I needed something a little bigger. This has an 8/1000 tip radius on it. This material is 17.4 pH stainless steel, and I think it's heat treated to a H1050, I believe, so it's kind of tough. I wanted something pretty strong for these screws, and that's what I found on the stock rack. And it machines pretty good. Not having any trouble. It is getting the part awfully hot. So I'm going to stop after this roughing a little bit and let it cool down a little bit before I take the finish cut. I've got a finish cut program. This isn't the finish cut. This roughing cycle, for some reason, has this pass afterwards. I guess it's a sort of a semi-finishing, rough finishing pass or something. I don't know. I saw it was doing it, but I didn't want to change it. It seems like it might not be that bad of a thing. So I'm going to blow this off a little bit. Try to cool the part down a little bit. Also, another reason we're not running coolant is for some reason the coolant pump wouldn't come on. I didn't want to mess with troubleshooting that right now. Part's still awfully hot, but we're going to go for the finish cut here. I don't get out here a lot in the garage, so these I need to do some maintenance work on these machines. Getting kind of here in Houston, we have a lot of humidity and stuff gets rusty. You see all this rust and stuff here. I need to do some work on the machines in the garage here. I just haven't really been out here that much this year. Haven't had a lot of time to do this. Gotta get this shaving off of here. Not a good idea to grab onto those shavings with your fingertips. Okay, so that's the turning part of this. Let's see what we do in here. It's not too bad. It's maybe 1/1000th big, but for a screw, that's okay. Now, I'm gonna go for our, it's a 12 millimeter, 1.5 pitch thread. Sure is nice to thread on a CNC machine. Don't have to worry about, disengaging the half nuts or stopping the spindle or anything. Just threads. It almost spoils you. After you do it like this for a while, you don't want to go back to the manual lathe at all. Okay. Now I'm going to back off the tailstock and try. I just have a nut here. I don't really have a gauge for this thread. So I've just been trying this nut on here. This isn't the absolute best way to check a thread in reality, because a nut always has clearance on it. So you actually have to make it a little bit loose. Extend the tail spinner. Now I'm putting a, for the purpose of what this part is doing, I'm putting an O-ring groove up here on the part. Pretty simple. I'm trying to get this to seal in the counterbore where the normal socketed cap screw went in this counterbore in the spindle face, and I want this to seal off any coolant that's getting in there because of the way I designed the way the coolant can be delivered on this this parallel spindle thing I made. It's going back. I originally had just these long socketed cap screws, but this isn't really sealing, and apparently coolant can get back up inside the spindle housing somehow, I think. I'm not 100% sure, but that's what I think is happening here. Now, if you're going to use a file like this, I don't recommend it, but if you're going to do it, don't grab it like this, because if that file grabs anything, it'll shove it right in your hand. If you're going to use a file without a handle, I don't really recommend doing it, but I don't have a handle for this file. Hold it in between your fingertips up here, like this, like you see me doing here. That way, if anything grabs that file, it'll just throw it out of your hands. And you don't ever want to hold a file like this, because it can just shove that tang right into your hand if it ever hits. This isn't really dangerous because there's no three-jaw chuck here, but if there was, that could be a problem. Could you accidentally hit the file on the jaws? Taking that burr off the front of the thread there. Hit it with a little Scotch-Brite. That's it. So that's the basically that operation. And then I'm doing 6 of these. I only need 4 of them, but I'm doing some spares. Then I got to turn it around and put it in a collet here on this diameter, and do the same thing. Basically, I'm going to turn the same thread on this end, and I'm going to leave a little area here for a short hex so that I can screw this in with the O-ring on there, and it goes into the screw that the Mazak already had holding a spindle face in there, and this will seal on the counterbore to keep any coolant from going back up in here. And then I'll be clamping my spindle attachment thing out here. So that's the first end of this part. So here again, change the tool number 1. Bring the tool up against the part to set the Z0 or the offset for that. Tell it to, it says Z measure on the Haas lathe here. You're ready to start the next part. Let's see if I can give you a different view of this. We're going to start this. On this little Haas lathe, I mostly just program manually at the control. On the Haas mill, I use the CAM software a lot, but on this lathe, I just do it at the control usually. Pretty simple stuff. Just seems easier than doing the whole CAM thing and uploading the program to the control and everything. That's what I usually do. This is a little small tip radius insert. It's got like an 8/1000 tip radius on it. I'm taking 30/1000 depth of cut. We'll turn in the maximum RPM. This little lathe will only turn 1800 RPM. So we're turning maximum RPM, 1800, 6,000 speed per revolution, 30/1000 depth of cut. 17.4 pH, H1050 material. This is getting pretty hot like this, turning like this. And as I say, I wanted to be able to see it for video purposes, and also I have trouble with the coolant pump, so I didn't want to mess with it right now. I've been pretty happy with this lathe, actually. This Haas lathe, this what is it, a TL1 they call it? It's actually a pretty nice little lathe. Unfortunately, it'll only turn 1800 RPM. But 1800 RPM is good enough for a lot of things. This is 10 millimeters in diameter, so this is still pretty darn hot. Really need coolant, but getting kind of lazy here, not putting it on, not fixing the coolant pump. But as I was saying, this TL1 lathe actually does pretty good. It's actually very precise. At least this one is. I don't know if this is true of all of them, but I can hit 1/1000th of an inch tolerance easy on this machine. No problem at all. Which you would think, you know, that's kind of surprising for the way this machine is built and the way it works and everything. Okay, let's check the diameter there just to be sure. It's right on size back there. It's about 1/1000th big out here, but I'm not going to worry about it. So I'm going to put the threading tool in here. You can see I got coolant lines on these tools, and it would be better, but Not happening today. Kind of shaking the camera over here. This machine has this handle on here to run it manually, but it's not balanced, and so when it reverses fast like that, it kind of shakes things. And where I got this camera mounted, it's kind of shaking the camera. I had to start real close to the end of this part here on the it's very close to the tail center. I'm only actually starting that thread on a CNC machine. It's kind of good to start the thread out a little ways from where the thread starts to give it a kind of chance to pick up the lead precisely. And I'm only starting like 50 thousandths with this tool away from the end of the part, because that's all the space I have without, or I'd hit the live center with the threading tool. But it seems to do that okay. Final thing is put this groove in here. It's kind of shaking. That's it. Okay. I didn't put any corner radiuses on this grooving tool. It's just a simple plunge into the part. Didn't want to make things too complicated here. Oh, let me show you something. Let me get a piece of if I have it here. I don't know if I have what I need. Maybe not. If you need to polish an O-ring groove or something like that, this finish is coming out good. But I've seen this. Well, I don't have what I need to show you how to do it. If I had some fine emery paper, what you do is you rip off a strip. If the groove is real narrow, or to do threads even, you can take a piece of emery cloth and you can rip off a thin strip of this stuff like this, and then you twist it up. You know, they do make this you know, these abrasive cords, I guess you call them. But if you don't have that, you can do this. You can twist it up tight, and then if you want to deburr the thread, you can, you know, just go down the thread like this. Sometimes it works better if you run it in reverse, in this case, because you want to come off the end of the thread. And you can do this
I don't really need to do that here, but I just want to, this isn't really fine enough. You know, this is like 80 grit or something. I don't know. Yeah, 80 grit. Normally it gets like about a 240 grit paper or something. And you can twist it up like that, kind of make it into a cord. And you can run it down these threads. I've seen people on YouTube, they're taking like a wire brush or something in there. But if you take a piece of emery, and you can just roll it against your pants really and just get twisted up into a tight cord like thing like this. And then you can just run it down the thread. It's kind of easier if you do it in reverse. I don't want to do too much of that on this because this is too coarse. You need about a 240 grit or something like that. And just twist it up like that. And it gets right down into the thread better, and it'll actually deburr it. A wire brush, you know, it doesn't really, it takes some of the big crud if you got lots of big things on there, but this will kind of polish it a little bit. And you can also use this technique in a narrow groove like this if you need to. That's just something that I've seen. It's not really my idea. I can't really lay claim to that, but I've seen people do it that way. And it's nice to thread on a CNC machine. See how nice that thread ends up looking? There's no, I'm turning 600 RPM. And of course the lead of the thread, but it'll do it. This machine will cut this thread wide open if I wanted to. 1800 RPM. But because I'm starting so close to the end of the part, I didn't want to run the too high a speed because it has to catch the lead before it gets to the first thread on the part. I'm only starting, like I said, like 50 thousandths out because of the clearance on the tail center. I would hit my tool back here on the tailstock. I'll run it. If I run it too far out in Z, kind of need for smaller parts like this, I need a tail center that has a smaller diameter here, even out on the tip of it, for better clearance on these kind of lay down tools, because they hit. I even ground a little bit off of here to get a little more clearance. Part that fits up in there. Maybe that will work. I'm going to put this on backwards. So that I can so I want to grab it about just barely in here, about that much maybe. Yeah. Not really a lot. So need to make some kind of wrenches for this setup. Let me see how that looks. Yeah, that might work. I just want to, I'm only holding on to just a very little bit of this diameter here. So let's get rid of this 3/4 inch collet. This one in its place. All right, now what I'm going to do is I'm going to just going to face that off. First, I'm going to change back to this tool. I'm just going to rough these off of here all the same. Not holding on to very much of that part in there. And all this is going to be supported with the tailstock, so it's not going to matter. I'm going to set that teach 0 there. I'm just going to face all these to that length if that works. Let's see. I'm just manually cranking this right now. Stop. And I'm going to center drill all those. Okay. One more. Right. Now, this other way. I'm going to try here. I'll get I'll put it here. I'll set it right. Okay. We'll do something. Yeah. See enough of it. I'm going to set it right here. Sit up to I'll put some water. All right. That's nice. So it's good. I'll call it a job. It's very light. It's very light. Cut it all the same length. If you wear like this, it's going to take. Let's have a job. It's very light. I'll do that. I'm going to use the back. What's that? That's all. Yeah. I'll lose this one step. We'll be done. That's one. Right. That's it. Now we got to make sure there's enough clearance for the tooling. Put the center on there. About right there. Extend the tailstock out here. Like that. Let's be ready to go. It's going to be our 0 point right there. And we're going to basically kind of do the similar thing. This is my This is my little sketch. I don't know if you can see it. Already turned this in. Got to turn this back and chamfer out here a little bit where this hex is going to be. It's going to be a 14 millimeter hex here. And then I got to thread 1 inch up minimum up here, same thread as the other end. So I can pretty much modify the same program, I think. Modify the program, and we'll come back, turn the other end of these things. And then we've got to set it up in the mill to mill the little hex on there. The only reason for the hex mostly is so I can tighten it down in where the existing socketed cap screw goes, but I don't have to tighten it real tight, because then I can just the O-ring will make it seal. I don't know how coolant got through there because there's just blind tapped holes, but somehow maybe there's a gap between something in there. And I should have done this to begin with. I should have made this proper stud with the O-ring on here to seal. I think normally, well, I've got this kind of pressurized coolant in that gland area of that, so I can deliver the flood coolant out through a lock line hose to my offset spindle. And normally these screws are just screwed in there, and I guess they seal good enough, and there's not a lot of pressure pushing coolant up into the screw. But apparently there's some kind of the coolant could go up here and it could go between something in here. I'm not sure. Or I'm not even sure if that was the cause of it, but a little bit of coolant got back into the spindle, not the spindle part of the bearings and everything, but the outside area of the Mazax B axis. Didn't really appear to hurt anything, but I don't think it's a good idea, so I'm making these to prevent that from happening in the future. Number 2 in this case. Start the program. Basically the same as the other end, only just a little shorter. Right. And then the finish pass. Okay, get rid of these shavings. The threading tool. And that should be it. Let me back this tailstock off here. See if we can get those shavings off of there. That's it right there. All that's left to do is deburr it. Drop the nut on it. Well, now to back the tailstock off. See if I can find that nut. Bunch of shavings right here. Push them down here otherwise. And that's it. Made this a little bit longer than I drew on the drawing. Won't hurt. Okay, here's the setup in the little Haas. Just to mill the hex, I've got this thing sitting on a 5C collet block, and I've got a parallel underneath here, kind of sitting. These are custom jaws I made a long time ago that have this V in it, and it would hold the block vertical. I'm just milling this hex here. So it comes over, starts the spindle, comes down. Move you in a little bit closer here. Not running any coolant on this. It's not really necessary. It's not that heavy of a cut, really. This is easier than milling it like one flat at a time with a hex shaped collet block. So just a rough cut and then a finish cut. Pretty simple. Just like that. Just want to make sure the 14 millimeter wrench fits on it. Looks good. Now, you have to forgive me for what I'm going to do here because I couldn't find my wrench for this. So I'm just doing this for right now. Somewhere I've got a wrench or some kind of a thing I made up for that. I can't find it. I'm in a hurry. So let's mill in the hex. So the next one, stick it in here. Tighten it. So I've got this kind of parallel sitting on here. It's hitting against the end of the collet. Not a perfect setup for depth, but for this particular purpose, it's plenty adequate. That's it. Push cycle start, and so on. Pretty simple. Probably could have eliminated that upward movement, but not that big a deal. So that's all there is to that. Gonna have to make a decent wrench or something for this. Might even have to make some new nuts here, maybe. I don't really like these nuts that these things come with. these little round holes. I think a nut with notches in it that takes some kind of a wrench, kind of like goes on these bigger ER collet chucks, you know, here with these slots. Something like that would be better for this. This is just I don't know, these are just a cheap set I bought a long time ago. But anyway, that's, except for a little deburr here, which I got to do after I mill all of them. Got to deburr these things. Now, I don't have my I don't have my NSK grinder over here, but I do have, we used to use before we had those NSK grinders and stuff, we used to use these Dotco. Things turned off. These Dotco, these little Dotco air grinders. It's leaking a lot of air around here. These turn 100,000 RPM, which is kind of nice because the higher RPM it actually makes it easier to deburr. It's so high in RPM it just it's a little bit awkward doing it the way I'm doing it right here, trying to show you. Normally I'd do this probably at the bench, but you kind of want to climb mill, if you will, with these things. Because if you try to go the other direction, it grabs and it jumps around. See, this thing is I don't know if you can read that Dotco. It's just like a little turbine thing. Supposed to turn 100,000 RPM. Doesn't take much pressure. I got it running on. Can't read the gauge on this thing. About 60 psi. Gauge is kind of dirty on this. I got a gauge, little regulator thing I plug it in with. It's got a little, I don't know, this is a little filter thing on here too. Make sure, see what the pressure was. Yeah, it's 60 psi. And like I say, it's got a filter here because you don't want crud to come through your air system and into these bearings. Not sure if these have ceramic bearings in them or not, but bearings last a good while though. I haven't had any trouble with that. Anyway, I keep this thing in the garage. I have the NSK grinder, electric one, at the shop. Okay, I went into inspection and took some video of the parts sitting over there. Here's the one end of the counter bore. You'll notice the two small holes at the top of that
inside of the counterbore. I'll explain them later. And then this is the middle counterbore that I did with that parallel head inside this part. This part is made out of titanium. So that's the one in the middle of the part, the counterbore. I had to bore that hole, cut the groove in there. And then here's the other end, and there's those two 632 holes that I used the coolant powered L tool head to drill in there for those. So anyway, that's the video, and thanks for watching.